Hello students, welcome to our math online classes. Today's topic is going to talk about ratios. Well, ratios are a mathematical tool to comparison. We can compare books which are like this. These books look equal, same size, or could be compared with books with different types, different size, or objects like this beautiful car, which is bigger than this other one, which is smaller. Or also we can compare same object with different types of cars. So ratios are used for the following. One of the mathematical useful tool is called ratio. Ratio in Spanish means razón o comparación. Ratios are used to compare generally two quantities. We can also compare objects, we can compare people, we can compare units. How we do it? We usually have a quantity that could be a number or a quantity or a person, and we're going to call A. A is compared to B. The ways we can use the ratio are based on these two dots, which would mean, as you know, this represents a division. So A is to B. Also, the main form, the most useful form to express ratio is in the form of a fraction. As you know, we have a numerator and a denominator in the upper number and the lower number. So if we talk about numbers, we replace these values with these variables with values. Like the terminology to express is 2 is to 8. 2 is to 8. Or another way of saying, I compare 2 with 8. So it reads A is to 8. Well, how do we write a ratio? A ratio could be written in words like how many goals does a team make in a football game, in a football match. So this is a rate that tells that this team makes 8 goals in 10 matches or 10 games. So it's showing us a comparison of effectivity. Basically, a ratio is written in the way of a fraction. And the upper number is called antecedent and the lower number is called consequent. That means that there is an action and there's a consequence of something that has happened. That's why we use in words something that is going to be compared with another action. Well, in general, ratios are equivalent. Why are they equivalent? Because 2/3 is one ratio that could be changed to a number by multiplying the same number on the upper number and the same number in the lower number. That means that I can multiply 6 times 2 on the numerator and 6 times 3 in the denominator. And I get 2 times 6, 12, 3 times 6, 18. 2/3 is equivalent to 12/18. Or I can also lower this ratio by dividing this ratio by the same number. As you can see here, 12 divided by 3 and 18 divided by 3 is going to give us 12 divided by 3, 4, and 8 divided by 3, 6. So we can have equivalence between 2/3, 12/18, and 4/6. It's very helpful because we can compare apples with apples, bananas with bananas. The idea is not to mix units. Like this, It's easier to find a comparison between something that you can see the difference. But it's difficult to tell the difference between this ratio. A car that goes 180 kilometers in 6 hours, or another car that goes 180 kilometers in 2 hours. Which car, A or B, is faster? So we need to find a unit rate. This unit rate is found when we divide the upper number and the lower number by the same denominator. So that if I divide 6 by 6, I will get 1. And then I can divide the upper number by the same denominator. So 880 divided by 6 is going to give me 30. But it's going to give me a unit rate that's telling me that this car is going to 30 kilometers in 1 hour. Let's see the difference with the other car. This car goes 180 kilometers in 2 hours. So to find the unit rate, I only have to divide the upper number and the lower number by the same denominator. In this case by 2, because 2 divided by 2 is going to give me 1. And 180 divided by 2 is going to be 90 kilometers per hour. Now I can tell the difference, because with based in the unit rate, I can see that car B is faster than car A, because 90 kilometers in 1 hour is bigger than 30 kilometers in 1 hour. That's the usefulness to have a ratio, and also a unit ratio. The main usefulness of a ratio is called proportions. Proportions give us a tool to compare two equivalent ratios. We can compare with this symbol. This symbol is going to give us an equivalence. As you know, 1:2 as 3:6. Or in other words, we can see in the fraction form, like 1/2 is equal to 3/6. The upper numbers are called means, and the lower numbers are called extremes. The basic principle of proportion in math says that the multiplications of their products, that means the means multiplied, are equal as the extremes multiplied. As you can see here, it's a cross product or a multiplication in a cross section. So if you can see, the first proportion in the numerator is multiplied to the denominator of the second proportion, as well as the second denominator is multiplied by the denominator of the second proportion. So what we are going to have is 1 times 6 is going to be equal to 2 times 3. As you can see, y times 6 is 6, 2 times 3 is 6. So the answer is 6. If this multiplication is equal, then our proportions are equivalent. This is very useful because proportions usually have 4 terms. 1, 2, 3, and 4. That means that we have 2 means and 2 extremes. And the main tool is that help us to find from 4 terms which 3 are known, 1 which is unknown. That's getting us the principle of an equation. Here we have a practical example. They tell us that in 2 cars we have 12 people. This is an American car because American cars are bigger, so they got 3 in the front and 3 in the back. That means that we have 6 people by car. But they are telling us that in 2 cars they got 12 people. The question is, how many cars do I need to take 30 people? As you can see, I am not only writing numbers, but I am also writing units or objects. But the main and most important part is that if I put cars on top, I should put cars also on top on the second proportion. If I put people in the bottom part of the first proportion, people should also go at the bottom part of the second proportion. Now I go to this property of cross product multiplication and I multiply 2 cars times 3 people. Okay? And then I have 2 cars multiplied by 36 people. Also, the numbers of cars that I don't know, I call x, is multiplied by 12 people. Well, I do the multiplication. So 12 times x is 12x. And 2 times 36 gives me 72 cars people. And I need to find out the value of x. So I use the inverse property of the numbers. As we remember, the inverse of multiplication is division. So since 12 is multiplying x, the inverse will be the division of the same number. So in order to cancel out 12, I divide both terms by 12, as you can see here. So I will get a cancellation. 12 divided by 12 is going to be 1. And 72 divided by 12 is going to give me 6. So I also can cancel out the names. So people are cancelled out with people. And the only thing that's left is XC. C stands for cars. 72 cars people, and we have 12 people. So people are cancelled out. So the only dimension left out is cars. So the answer will be that we need 6 cars to take out 36 people. It's very important then to say that the final answer will see that we have 6 cars. And this is the usefulness of a proportion to find of 3 knowns, 1 unknown. And it's very useful in daily lifetime for solving all the problems that we can think about proportions based on comparison operations. Again, I would tell you that I expect you take care of yourself very well, don't go out, study hard and have fun. God bless you.